field report from a very, I think, relevant problem for a lot of people. 0 search results and how to handle them. They also applied for, I think, the longest title award for this conference. So the talk is about strategies for using alternative queries to mitigate 0 results and their application to online marketplaces.
Yeah, thank you.
Thank you.
We didn't want to. Yeah, please go. Okay. Yeah, we didn't want to leave any doubt about what this talk is, and put it all in the title. It's about solving this problem of 0 result queries that can impede e-commerce platforms badly. The strategy is using alternative queries, and we look at this from 2 perspectives, from a more general perspective and from this actual application to the online marketplace that Wallapop is. I think I've introduced myself yesterday enough, but I want to mention one thing. I'm also co-founder and organizer of MySys, Mixed-Camp E-Commerce Search, which usually happens in this room in June, right after Berlin Buzzwords. And on this note of Women of Search, we have the same problem as a conference. And I think there are some things that you can do as a conference organizer to encourage women, but still it depends on the community and not just the organizers. And over to Jean.
Yeah, my name is Jean. I am a search engineer at Wallapop today, and I started working as a software engineer. I think not most, but many of us started as a software engineer. We start coding, and then we fall in love by search because they give you a MySQL database and you have to do search. So yeah, and I have worked in different industries such as traveling, e-commerce, and right now in classified ads. I'm married, I have 2 daughters and a female dog, so I understand the women of search, the importance of it. I'm the only man at house. So yeah. The company I work for, Wallapop, is leading platform in conscious and human consumption. So we want to make the buying process more sustainable to the world. And we are present in Spain, mainly in Italy as well, also Portugal. We have more than 70 million users in the south of Europe, and we are getting closer and closer to 1 billion articles sold in the past 10 years. So we are changing little by little the world and the consumption, how it is currently working in the world. Our team, we are made of search engineers, product manager, principal search engineer, front ends, engineer managers, data scientists, and analytics. So we have a complete, not super big, but a complete team. And yeah. The problem we have, Wallapop business domain, classified ads, we allow everything, everyone to sell almost everything, basically. So you have a lot of different user-generated content. So it's pretty likely that they will put in misspellings and things like this, so it will make the search a little bit hard, and we have to deal with this. We have diverse type of queries, locality filter, because 10 years ago, when the company was born, basically changed the Spain market because people could search for things around them. So we have still, although we are relevant, like guided through relevancy, we have also locality filters, so people can search things around them, but also in other countries as well. So it's difficult to say what is relevant for someone buying something from Italy, in Spain, and vice versa. So we focus a lot of our power into focus on precision, basically. Precision of the searches are super important. And right now, what we want to do is to mitigate these results that we have in our company in our search bar, to make it a priority, basically.
Yeah, if we approach the problem of 0 results, we might think of quite a variety of strategies, and some of these strategies tend more towards fixing the query, fixing the search, and some become more about recommending things, but not fixing the query. I've actually given a talk about query relaxation back in 2019 at Haystack US, and I also listed the strategies there. but I want to add a few references to that talk, but I think it makes sense to remember those strategies. So better text analysis, better stemma, maybe. That's what we learned from Lucien yesterday. Synonyms, hyponyms, however we come up with them. Spelling correction, did you mean, is a way out of zero search results. Change the content or add additional content that you search. Maybe low quality data fields, play with the Boolean constraints, move from and to or minimum should match in Solr, Elasticsearch, OpenSearch. Could add hypernyms, so that gets a bit more general. If the query is boots, I might also search for shoes if boots yields 0 results. Then there's query relaxation, iPhone 13. We don't have an iPhone 13, but we have iPhones. Relax the query that way. And then you move to even more distant relationships. Yeah, so someone searches for bed balm. I show them a trimmer. Yeah, so that gets into the realm of recommendations. Yeah, so that's basically it. And we leave the query context more and more. But now this new space of vector search could also help us maybe. Yeah, so maybe we could just retrieve results for that zero search result queries by help of vector search.
Vector search looks promising for Wallapop. So I think for everyone, and we've seen a lot of talks about this yesterday, for example, and also today, it needs least medium-term development. So we would have to invest a little bit more of time, and we will, and we are doing that. What makes it a little bit challenging for us right now is that we have a lot of documents. Most of them will be out of the business soon because we hopefully found another home for this item. And adding embeddings for this all the time can be challenging and costly. So we are taking this into other fronts. We'll come back to this later. And what we are doing now is using simple approaches that all of us, if we didn't do it yet, we can do. And we will come back to this a little bit later.
Yeah, so coming back to the strategies for zero search results, Wallapop had already done a number of them. They even contributed a new stemma for Spanish to Lucene. So that is reasonably solved, I think. Synonyms, hyponyms, spelling correction, all this has been done. Content was extended in a way that the geographical distance within the potential buyer would search would be broadened for some queries. We saw a talk at MISIS last year about that. And even loosening Boolean constraints had been done, so we needed something new. And they remembered I had been working on query relaxation, so we thought, okay, can we do query relaxation, but maybe with the means of 2023? Yeah, so we have large language models around. Can we improve on those strategies? And can we maybe look into other ways to find alternative queries? Yeah, so if I relax the query from iPhone 13 to iPhone, that's a way of coming up with an alternative queries, but there could also be a different way by replacing tokens. Yeah, so in this example, Audi A1, I would keep the make of the car, but then say I want to have an Audi A2, a different model. Yeah, so that's the two strategies for using or for coming up with alternative queries. So let's start with query relaxation. I don't want to repeat my talk from 2019, but as I said, I want to point out a few strategies. But let's start with the intuition. So what we do is we drop one query term that makes the query less specific. We know we will not exactly fulfill the intent that the user was looking for. It's broadening and sometimes quite different, but still we find a relation to the original query. That means the user might still engage with our website and not be left with an empty result page. There's also a nice UX property of using alternative queries. So here we have this query iPhone 14 mini entered by the user. I think there's no iPhone 14 mini. So we would drop the term 14 and we have a nice UX pattern here that we can show, okay, we dropped that term. Yeah, so that makes what we did explainable. The user understands for which query we are showing results for, and that this is not the original query that they entered. And then the user might decide that they change the query. Yeah, so they say, okay, that's what was searched for. Maybe I looked at the results, and iPhone 13 mini is a good thing, telling on the results. So they can modify the query. Yeah, so it's a nice interactive pattern and a nicely explainable pattern in terms of UX. The key question is, which query term shall we drop? Yeah, and this can get quite funny. If we have a query iPhone 14, I think the intuition would be to drop the 14 and go with iPhone. If you dropped iPhone, yeah, so that query term, we would be left with 14. Yeah, so searching for 14 doesn't make much sense. The next query is a bit more difficult. So this example of Audi A4, make and a model. We could drop the model A4 and be left with Audi. But we might also drop the Audi and be left with the A4. And depending on the context, that might work or might not. A4 is a paper size and a model of the car. Yeah, so if our site is strongly constrained to vehicles, cars, A4 might be the perfect thing. Maybe we still won't find anything because it's the only brand or the only make. But in theory, that would be possible. Maybe someone forgot to tag the make, and then we could keep the make. And then in what follows, I'm quoting some examples from 2019. So let's first look at black shoes. Being left with black might be difficult. Shoes would be the query we would go with. If someone searches for purple shoes in a fashion domain, maybe we could even drop shoes because purple is such a specific thing. Someone wants to dress in purple. Yeah, so maybe they might be interested in purple socks as well. And then we have queries like USB charger, 12 volt. That's super difficult to tell which one to drop here. They all are kind of a constituent of the meaning of that query. And it's hard to drop any of those. Related to the talk back in 2019, I got a lot of questions about the data sets that are used for evaluation when I presented strategies and how do we come up with those? And how do we evaluate? And Jean is explaining a bit later how he processed the data. But basically what we need is always pairs of queries, a long query and a short query. Yeah, so in this example, pisos alquiler, rooms for rent, that's a long query. And then pisos rooms is the short query. Yeah, so the long query probably has no matches or might have no matches, but the short one should have matches or must have matches in this context. Or coches baratos, cheap cars, coches is the query that we want to use. Yeah, so the cars. And so on. So what we can do now is label the queries and tell which term shall we drop. What's the index of that term that we drop? So in this first example, we drop the to rent alquiler and keep the pisos. So zero-based index here would be 1. Yeah. So and so on. And it's not always the last term, but in Spanish it often is. And but then last example would be a counter example. Yeah, Apple Watch, we drop the term at index position 1. And then we can look at what our algorithm does. Yeah, so what did we predict? What does our algorithm tell us? And then measure how much they overlap, and maybe use accuracy as a evaluation metric. So here in this case, 3 out of 4 were correctly predicted. But we could also look at other metrics. So maybe an algorithm says, I can't bring back any prediction which term to drop, and then we would have to look at recall and position separately. So this is a slide copied from 2019, and it lists in per row all the algorithms that I examined at the time. And the winner variant is, or the winner algorithm is highlighted. Let's just, so I used different data sets, and these were the metrics that I used at the time. And precision, that's mainly related to accuracy with some examples, recall and F1 out of that. And then, as I said, the algorithms. And I don't want to go again through all of them, but just highlight a few and discuss a few, and then see where we are in 2023. So the first one is the most intuitive. If we look at the query like iPhone 15, and we would say, drop the shortest non-alphabetical term. Yeah, just drop the 15 shortest. There's something like Zipf's law, it might be contain less meaning. And then we got, let's say that's accuracy or compared to accuracy of 0.52, so half of them were right. And then we got a recall of 0.05. So that means nice as the intuition is, but not all queries have a non-alphanumerical term, a non-alphabetical term in it. Not all queries have a number in them. So that nice as the intuition is, it's not as powerful. It has a very low coverage. Drop the least frequent term. So teams with whom I've worked prefer this solution usually if they cannot ramp up ML. So what it means is I look which of the query terms has the lowest frequency in my index. Yeah, so simple term statistics. And this gets quite high. Yeah, so that's already very powerful, 0.79. And then I started examining at the time embeddings-based algorithms. So that would mean I would look at the, at the time I used word embedding. So I used the word embedding for each query term, aggregated that and got an embedding, and then looked at what's the difference or the similarity between the original query and the manipulated query, and choose the candidate with the lowest difference or with the highest similarity with the original query. I explained it a bit more in a bit. I just wanted to say that there are different ways of coming up with embeddings. So at the time I used word to vec and then aggregated, as I just described, the word embeddings. There could also be query to vec. So imagine the sentence is not a sentence of words, but a sentence could also be a sequence of user interactions, and then an individual query could represent that word. So we had embeddings for individual queries. And the problem with that at the time was that the recall was very low because this only is applicable to known queries. Yeah, so if you have to go back to your previous sessions, then you have to know that query. This is a nice case where we could start thinking about LLMs. Yeah, an LLM would give us an embedding for any sequence, and we could try to use that and replace the embedding, how I trained it at the time, using embeddings from a large language model. And that's basically what I tried. So instead of going to the traditional embeddings models, I use a mini LLM for that, but there could be other models. So I would create or use the embedding for these three queries. So the original query, iPhone 15, the query 15, and the query iPhone, and see how closely they are mapped into the vector space. And basically that's what we hope for. Yeah, so original query and iPhone would be closely related, and then the 15 would be somewhere else in a different corner in that space, and then pick the query with the greatest similarity. So this worked kind of, but not super great. But on the other hand, the recall improved. Yeah, as I said, we always we don't have to rely on queries, or there's no constraint on queries that we have previously seen. But also the metric is not super high. A bit of a heads up, this is a different data set now and a different language. So this time it's Spanish. At the time I had worked with German, French, and English. So it's hardly comparable, but get the approximate magnitude. So then I, of course, wanted to try out the winner from last time and see how I could improve the winner. And I have to explain this winner variant, and it used a multi-layer neural network under the hood, and it worked like that. So the input was at the time mapped to word embeddings. I used 300 dimensions at the time and realized I only need 50 or 30. But anyway, when I presented it, that was like it was. And so each input would get its embedding. And then I trained a little neural network, and the network would have to predict which term we drop. Yeah, so here we say this is not to be dropped, the second one is to be dropped, and the others also zeros. Yeah, so we look at the term for which you get the highest probability from the model, and that's basically how it worked. In addition to the embeddings, to the word embeddings, I added three or values for three more features. So I added three dimensions. They were related to the word shape. Yeah, so how many characters does this word have? 4, 5, 2. And also how many digits I have. Yeah, so here's 2, 0, 0. And then a bit of NLP voodoo. Do I have an E within the last two characters in that word? So I don't want to go into the details of that, but this is how it was set up. And I repeated the experiment this time, and I got a very high value here. And I scratched my head, how can it be 0.98? Yeah, so last time was so low. And I think I changed two things. One was, it's a different language. Maybe the position at which I drop is a bit more streamlined in Spanish, but this is probably the minor thing. The other thing is, at the time I had cheated a bit. Yeah, so this is what I presented to the audience, Nike Boots 11, but under the hood, I had still sorted the terms in alphabetical order. I did this to get more information from analytics per term. So I aggregated Nike Boots 11, Boots 11 Nike into the same query. Yeah, so, and I always sorted this. And this threw away the positional information, which I did not do this time. Yeah, so basically, I applied a fix, and I did not ignore token order this time, and I got this crazy high value. Yeah, so if you get 0.98, you usually stop. Yeah, so it's overfitting maybe, and it's good, and you're done. Nevertheless, I still wanted to know, because when I do this, I depend on having a word embedding. Can I still replace this by using a large language model? And that was my next experiment. So there was a few more. But basically what I did is I used my query as it was, no manipulation of token order, and tokenized this and used it as an input to my model here. And that was a Roberta model that was fine-tuned as a classifier. And the classifier was to predict the token position at which I would drop, what I did last time. Yeah, so that's a very slim framework. Just use your text as an input and fine-tune a classifier model and predict where to drop the query term. And the fine-tuning just took 4 epochs, and then I was at the same values like with my word embeddings model. But this time I did not have to rely on pre-trained word embeddings, but could use the model straight away. And then if you think about improving this further, basically 0.998 means our model represents the data set. Yeah, so if you want to improve, we would have to come up with a better data set. Yeah, so find different pairs that are more likely to please the user, which you want to predict. So these were the experiments on query relaxation, and Jean will in a bit explain the route that the team then went on. But there's also this other strategy that I mentioned initially, using token replacement. So instead of dropping the query term like in query relaxation, we would say we go from ORDI A1 to ORDI A2. And this is a bit, there's a chance that this is more concrete and the user might interact with that more specifically. Still, you know, we will not match exactly what they want. So there are a few techniques around to come up with this. And some of them use an embeddings model and use the same strategy that we used for query similarity when we wanted to relax the query. And basically, we look at the embedding, original query, or the A3 in this case, and or the A4, and let's say paper A4 are the candidates. Then we would hope that all the A3 and all the A4 would be closer to each other than paper A4 and or the A3. And these techniques are often combined with some string similarities or just rely on string similarity. So it's not just a reliance on the embeddings. There was a nice talk from Mariano Semmelmann at the PyData meetup here in Berlin, and he showed like they used it in a classified ads environment as well. If you want to go back 4 years in time or 3 years. Again, this can be known to known queries if you use traditional approaches. So you would have to know your query. Yeah, so if I map this to the vector space, these are all known queries. And I thought, can't we try out a generative model so that we don't rely on known queries? And one idea that sprang to mind was a fine-tuned fill mask model. So fill mask models basically complete the text. Yeah, you say this is a new, and then you have a masking token, and the model would generate a token to fall into that slot. And the token could be at any position or even be a part of a word. And that was an experiment that was run based on 400,000 queries. So the model was fine-tuned based on 400,000 queries. So we can't just go with the text. We have to fine-tune for our environment and use query text. So the procedure was like that. Yeah, so we try to predict the term first where we would drop the query, where we would replace the token. And so that was the first attempt to say, okay, we need to generate a token at a certain position. So where does this masking token go? And we could use our best algorithm from query relaxation to do that. In the second step, we would use our fill mask model to come up with a number of candidates and finally pick a candidate. And the example here shows the output of the model, and the input was all the A1, and we got a number of suggestions from the model. RDTT was the top suggestion, and RDA2 is further down here, which would have been the better one. And what I thought what we could do is apply an additional step of still some string similarity. So the idea would be to that model numbers that we think we can replace would have certain string similarity, so that we could say, okay, A2 and A2 down here and A1 in as the original token would have a certain similarity and not use the TT here. So we have not measured this systematically, but I want to share a few insights. It's quite interesting what we get as suggestions. So this Pisos Alquiler that you might remember, rooms to rent, relaxed query would have been Pisos. So we would replace Alquiler, and we got Pisos Asturias, yeah, rooms in Asturias, which might work, might not work, depending on where the user is. Coches baratos, coches would be the relaxed queries, coches camping, not so good. Yeah? So cheap cars to camping cars, probably not a good one. Electric scooter, old scooter, or antique scooter, not that good. So some of them look really nice, especially the model numbers. So they benefited from the kind of string processing. And but sometimes it's some of these are not working well. Honda Civic was the original query. Honda, it's filling a model, but Honda CB is a boat actually. So yeah, so the model needs more information, I think. So this is more like an inspirational exercise here. But one thing we might maybe do from that is maybe you have a query like RDA1, and then do our query relaxation, but maybe boost on a query that comes out from this model so that we might bring some interesting results to the top. Yeah, so maybe we can exploit it in that way. And now what you put into practice.
Yeah. Now what did we do out to Wallapop? Well, as mentioned before, we want to start simpler, iterate faster, get online results back and get back to factory to adjust, right? So what we started doing is we dropped the least frequent term from the search query. The step-by-step will be presented soon, but basically the reasons are what I mentioned before. We want to be fast, we need to operate at a scale. With complex machine learning models in production, we would need more time to maintain this. We don't want to do that. No, we want to, and we are in the backstage. But for now, what we need to put in production, the simpler approach will be enough for now, right? So we will do it iteratively, and later on, we get back to the advanced techniques. The limitations that we see, there are many, of course, but the document frequency is not an always correct approach to tokenize, to select the tokens, no? Dropping the least frequent term in a query can sometimes be bad because the least frequent actually can be the most important, right? So we can get wrong there. Coming back to the examples that René gave before, we need the data for the offline evaluation, no? And maybe for the training later on. So what we did was to get the long queries, which means queries that have at least 2 tokens, and we will try to generate the combination of this smaller version of the queries and look in the logs in the historical data that we have. And if someone looked for flats for rent, pisos alquiler, but didn't find something, but someone else looked for pisos, which is flats, then we may use this one, right? It's best, even this René mentioned multiple times for us, that you find the queries in the same session, no? I am looking for iPhone 14 and I don't find it. I give up and I try iPhone only. In the same session, maybe you get better results. So what we had, we went to our database, we got historical data, let's say 30 days or something like this, filtered for all the queries that had at least 2 tokens and returns results, so no result queries. And we did the same, but the opposite. So we got queries, then we don't limit the amount of tokens and so on, but that returns no results. So we are preparing the data set that we will use. What you did do next, you clean your input data, you lowercase, you remove tokens that you want to remove, keep the ones that you want to keep, characters as well, depending on the language you are dealing with. You sort of create an analysis chain, as simple as you can, but an analysis chain, no? You generate the combinations for these long queries and with a missing token. And these are the relaxed query candidates that you will use. In below, you can see the example, iPhone 14 Plus, and then the candidates would be iPhone 14, iPhone Plus, and 14 Plus. So what you have to do, you go back and look in your historical data how many times they happened in these, let's say, 30 days, and count and save this for later because you're going to need. Here is an example, inexistent, but it can be true. iPhone 14 happened, I don't know, 150 times. iPhone Plus only 1 time, and 14 Plus we didn't find. So what you will end up with is technically this. Of course, we will need way more data than this. It's just an example, but we have the first call on the search term with 0 results, iPhone 14 Plus. And the example of the relaxed query that you have, iPhone 14, how many times they happened, and according to the algorithm that you create, is it the best one of the options for the same search term or not? And if it's acceptable, because some of them will not be acceptable, such as this one. I mean, it's better than 0 results. I don't know, because maybe we will have no results again if we keep this one. And the third one, if you remember, we did not find, so we don't keep it there. It's not necessary. You save it as a TSV if you don't want to trouble with commas and so on. And this is going to be the data set that you're going to use. So what you need to do next is to find which is the token that you want to remove. or the ones that you want to keep, right? So you go back to, in our case, solar. You can do this using the search terms component, and you get how many times the tokens that you have happen in the index. You track that. You have to make a lot of queries to Solar, do it in production, of course. No, I'm just kidding. And fire them, solve the save the number of times they happen in the index, save it as a JSON file, then you can use as a Python dictionary later on. You wish, you do whatever you prefer, but basically you need to have a lot of document frequencies here, because you have a lot of queries and you split them, the queries by space, for example, if you were talking about Latin languages, and you have way more tokens to ask for Solar or for Elasticsearch or whatever. Then we need to do what? We need to evaluate the data sets. So we generated the label data set before. We split the long queries by space, and we took the document frequency of all of them. So we load them into memory in Python or whatever we have. Then we drop the term with the lowest document frequency. This is super simplistic. I put here depending on your algorithm, because I can tell you what did I try with. Not only the document frequency, but maybe you can also try to remove first stop words. I don't know. Maybe you want to remove before duplicated tokens. You know, maybe if you have, I don't know, I cannot think of an example now that makes sense, but coches baratos, like cheap cars, coches baratos coches. Why not to drop coches, you know, because it's duplicated. You can get super creative there and try, and then you will see what the prediction will be in the end. What you have to do is that you add a prediction column in zero-based, as René said in the beginning, position in the data set. So you can say, okay, I labeled that I should have dropped this term, and I dropped this term. So basically, you have to check the accuracy of your model, counting how many times the label was correctly predicted. In our case, this is an offline test, of course, we got about 80% of accuracy. So that's why I want to empower to do the simple stuff as well, because what we do, well, I'm going to talk soon, but what we will do next is like, how does this correlate with A/B tests in production? We're going to do this super soon.
Okay, so to conclude this and provide a bit of an outlook, so we've looked at two major strategies to find alternative queries: query relaxation, token replacement, a focus on query relaxation. And these strategies of finding alternative queries have a nice UX. Yeah, we can explain it and users can interact with that. The quality that we measured offline points at the fact that our models can pick up what we feed them. So to improve that further, we need better data, like session-based data, for instance. Alternative queries, that was early days, hard to test, and a variety of semantic problems there. So that needs a bit more insight. But last but not least, this is a nice application of this creativity. Yeah, so we get these models, what can we do with them? And that can solve user experience quite nicely and very precisely. And then putting solutions into practice. So Wallapop decided to put into an online test the simpler solution, but then they get feedback quite fast. Yeah, so you still need your guardrails, that you don't break a lot of things. That comes from offline evaluation. But then and it worked pretty well. But then you need the feedback quickly from the users. Does this work at all for us? Where do we put it? How do they interact with it? And even gather more data. So I think the A/B test is imminent, and then the team will iterate on the implementation. And I think that's
that's it. And hopefully we can come next year and see how it went. That's it. Okay. Thank you very much.
Thank you very much for your talk. I have one online question from Andreas. It might partially be answered already in the conclusion, but let me still point it out. did you have a particular reason to stick to query relaxation and single token replacement? He assumes maybe to avoid the noise. Did you try an embedding approach without this single token restriction? For example, using user queries and feed. This needs some more filtering of candidates, yet extends the use case. For example, you could replace something like zucchini noodle with zoodle. And he's curious whether you found the effort trade-off favorable in your case.
First part, yes. Second part, no. So we considered it, and I think it's a broad field. And I think it's not just the algorithmic part of it. It's also the user interaction. Yeah, so we would change more what would it do with the user. So we would start simple. Yeah, so I think that's basically the answer. But it's a nice idea, and I think it would have to go back to session data also to see what queries match, and a lot more understanding. And is it worth it? I think we should get started simple and try that out online, how users interact.
Question?
Thank you for your talk. It was very interesting. And I have seen on e-commerce sites that they propose several alternative queries on our result pages. And then they also give the number of the results. And I just have to click on them. And have you tried this? Because I think it would give us the perfect training set, because we could see which one has the better conversion rate.
Well, we did not try it yet. We are going to test the A/B first with the simpler approach, really simpler approach. We are really focusing on getting this in production as soon as possible to get the data. But it's a nice idea. Also, thank you very much for that. We will use it maybe, and but we didn't do it yet. But it's nice, and also the combination. What you are mentioning is super important, which is like also the UX part of it. You know, you have to show two options, give the user the opportunity to choose. It's not just algorithmically choose, I think this is the best for you because I know my business. So I like your approach as well. You think about the UX, the UI, how to propose and select whatever is best and gather more data for the future, no?
I think key to that would be how you present it. I'm not convinced in numbers. How many matches would I get would convince the user, but maybe already showing some results, maybe in a carousel layout. Could help, but then you get biases, so it gets quite complex to evaluate that feedback that you get there.
Yeah, I was wondering, when do you consider a zero result? Like maybe there are some 1-2 results, but they're really bad, and then the relaxation kicks in, but maybe you don't want to do that for 0, but maybe already for a few. And how do you determine when to do the relaxation?
I take that. That's a very interesting question, and it leads to a conversation where Stefan we had yesterday over drinks. What's the perfect number of results? Yeah, so is it better to show, let's say, 9 precise results, and that's all we show, or is it better to show 15 results with 13 of them precise? I don't know. Yeah, so we have to figure this out. And this goes into cognitive research, and this is hard to pin down, I would say. We need to test for that. I think the best way is to really get started with either just kicking in true 0 result situations, or at least say, okay, we only found these results. You don't have to say only, but you could say we found these results. You might also be interested in, and then give them the additional results and tell them what they are for.
This kind of follows up to that, but a lot of times in the work I do, I'll have like a modifier at the end. So say like non-compete agreements, New York, and that's a very important. The question is irrelevant for other places. But it comes at the end of the query, so it seems like it'd be a good candidate for relaxation. But if we did that in this use case, it'd be useless. So I don't know if you guys had a similar problem or like strategies you came up with to get around something like that.
I think the positional information is quite key. That was also visible in my bug that I fixed, right? But it's not always the last position that might be negotiable. And you might also break things in the middle of the word, yeah, like in New York. And it might also interfere or depend on the language that we are using. Yeah? Like Roman language is quite head initial and the modifier comes after that, but that might not be the case in all languages.
Thank you. I have another question. So far, whatever you have presented, it's revolving around the strings. Suppose that I have a use case where a user is looking for a car model 2020. I want to also show that maybe he is also interested in 2019 model. And maybe another example could be their max budget is 20,000, but I also can show a car with 28,500. How to relax these numerical things.
Yeah. So I assume it's based on filters, and then you not necessarily. Okay. So, but overall, it's similar. You can figure out what is kind of negotiable to the users. Yeah. So make model sometimes is, sometimes not. Might depend on the actual make. But I think in this domain, then you would really have to go to session data and see how single users modify their queries and then generalize that.
Hi, thanks for the great talk. I have a pretty short question. So which metric are you using in this A/B test?
Oof. We will think about this. My product manager is gonna watch this. It's important to mention this. She will think about it, but we have some guardrails, so we don't want to deteriorate some things, you know. So this is super important, and it's iterative. We don't want, we want to improve by 10, by 15%, whatever, but we know that it's not realistic in the first stage. So we will probably look for the buys, the products that were bought. But we will also look at the markets that we don't want to deteriorate, or you know, there are many factors into this equation. But basically, it's this. We have to look at the numbers that will make our users satisfied, but also the company satisfied. We don't want to deteriorate any of the two sides. It's a difficult question to answer. I'm sorry.
But I think you've highlighted the most important metrics for your case. I would say one more general metric that you would look at here could be exit rate. Yes, the user enters a query, no results, leaves the site. You want to reduce that. Yeah? So that's the main objective of this. So keep them engaged. Yeah? We know we can't match the intent by manipulating the query, except if it's a spelling correction. But then the main thing is keep them on the site.
Okay, we've got one more online question from Angel. You mentioned that you have used a data set of 400,000 queries to fine-tune the models. Any information about public data sets or any plans to release your data set, maybe?
Public data set.
Are you aware of any public data sets for query correction that you can use for training?
I would say this doesn't really make sense. Yeah, so sorry that it might be sound a bit rude, but it's always about your users. Yeah, so you have to adjust this to your domain, and the data sets are not rocket science. Yeah? So as long as you have query logs, you can do that. Yeah, you only need, as shown laid out, the long query and the short query. Yeah, so and the short query must be a sub query of the long query.
Yeah, I think this is the most important thing, like what the person would like to have, because normally the data sets are something like confidential and super important. That's not this case here. What is confidential, which is not. But super important is like how we do it. And we've seen how we do it. It's super simple, not rocket science, as René said, not new, but effective somehow. Yeah. So
and fine tuning, I don't know if I needed 400K queries, to be honest. I just had them, so I didn't try to minimize that. And didn't take that long. I think, I don't know how many epochs it ran, but I think it was done in 2 or 3 hours. So it's pretty quick. On CPU, by the way.
Thanks for the talk. So just 2 quick questions. So what's the baseline solution? So do you only, for implementing this kind of dropping of terms, do you just do like full match, or do you allow like kind of any search or fuzzy search as a fallback mechanism, or you just don't want to do that and you'd rather go in the 0 results? So like what's the baseline? And the other one is that like how, if you could say roughly the 0 result with the current solution, and then how much you anticipate to drop with your current strategy.
Maybe one.
I can try to answer maybe more questions that I will remember, but the first one you asked was about the process. No, so yes, we do precise search. That was the focus till not long ago. So let's say minimum match should be 100%, but then after that we can do the minimum should match, which takes out the token for us, but we cannot choose, and sometimes it does weird things. So we have this in place. So super precise, a little bit less precise than that. And now we want to start iterating on the things that we have more control based on the user's interaction. So we will look at what have made sense to them and bring us to the algorithm. I think I answered partially something, but not everything.
Yeah, I want to kick in a bit. So, so you usually think in terms of search passes. Yeah, so precise first, and if you don't get back anything, use a more relaxed path, and usually spelling correction is the next one. Yeah, so that would be fixing the query, and using Boolean constraints, using or minimum should match. I'm not a fan of because it has this bad explainability, that bad UX. But maybe query relaxation can replace that at some point. So that's the usual steps here. Yeah. And increase. What I have seen, I think, is teams got solved their 0 result queries down by, let's say, 20–25%. So that's what I've seen in practice.
Okay, we're at time. So let's thank René and Jean again